Many people see NMN as a simple energy booster, like a cup of coffee. That view is incomplete. Inside the cell, NMN is a control input, not just another molecule for your shelf. It is information that instructs resource allocation. It influences repair prioritization and cell fate decisions, and helps maintain cellular identity over time. Calling it just energy is like calling a baton a stick. The power is in the signals it carries and the system it directs. This deep dive is for researchers, clinicians, and serious biohackers who want the operating system view. Your body runs on efficiency. It recycles NAD+ rather than building it from scratch. This is the NAD+ salvage pathway. Nicotinamide becomes NMN, then NAD+, and back again. NAMPT is the bottleneck that sets the speed. With age and inflammation, NAMPT slows, while NAD+ demand rises. DNA damage increases, PARPs consume more, the pool drains. Energy production and repair both suffer. Supplying NMN bypasses the bottleneck. Cells rapidly convert NMN to NAD+, restoring the recycling engine's flow. For years, critics argued NMN couldn't enter cells intact. They proposed conversion to NR first, then back to NMN inside, but the speed of NMN effects didn't fit that model. Enter Slc12a8, a dedicated NMN transporter. It moves NMN into cells intact, an express lane, highly expressed in gut, liver, pancreas, and aging tissues. Sublingual NMN bypasses gut breakdown and first-pass liver metabolism. Cells pull in NMN quickly, spiking intracellular NAD+. This direct transport helps explain why NMN feels distinct. A specific importer underscores NMN's importance, and its regulation shifts with age and metabolism. Once NMN becomes NAD+, the real work begins. NAD+ powers respiration, but it also signals. Cells read NAD+ levels to adjust high-level decisions. First, sirtuins, guardians of the genome. Sirt1 stabilizes the nucleus. Sirt3 protects mitochondria. Sirt6 aids telomeres and metabolism. They require NAD+ to work. With enough NAD+, sirtuins reinforce repair, energy, and inflammation control. Declining NAD+ turns sirtuins down, exposing cells to damage. Refueling with NMN restores their protective duties. Second, PARPs, first responders to DNA breaks, powerful but hungry for NAD+. In aging, overactivation can drain the pool and trigger an energy crisis. Replenishing NAD+ supports repair without collapse. Finally, CD38, the NAD+ leak that rises with age and inflammation. It siphons the same pool others need. Strategies pair NMN with CD38 dampeners like epigenetic and quercetin to preserve NAD+. Aging is in large part a loss of information. DNA rarely changes. Software does. The epigenome. Epigenetic patterns define identity and function. With age, marks drift, creating epigenetic noise. Sirtuins, especially Sirt1 and Sirt6, maintain chromatin structure. They silence what should be silent and keep needed genes accessible. Low NAD+ weakens control, confusing identity and function. Elevating NAD+ restores sirtuin policing. In animals, NAD+ restoration partially reverses epigenetic age. We are not changing DNA, just restoring how it's read. Supporting epigenome integrity preserves identity and function. That's information repair, not cosmetic anti-aging. Mitochondria make ATP and orchestrate signals. With age, networks fragment and leak electrons. NAD+ drives the electron transport chain. It also fuels Sirt3, the mitochondrial quality control lead. Sirt3 activates proteins, improves efficiency, and limits ROS. When NAD+ falls, energy and resilience drop. NMN replenishes pools and restores throughput. Sirt3 re-engages, cutting ROS leakage. The cellular power grid stabilizes. Users report clean stamina, endurance, heat-cold tolerance, cognitive steadiness. Better output with less oxidative wear, more energy per oxygen, without stimulation. Every cell keeps time. Circadian rhythms govern sleep, hormones, and metabolism. Light syncs the brain, metabolism syncs peripheral clocks. NAD+ oscillates daily, high by day, low at night. Clock and BML1 drive, NAMPT, Sirt1, fueled by NAD+, tunes the clock, a reciprocal loop. With age, amplitude flattens, timing weakens. Morning NMN amplifies the daytime NAD+ peak. It reinforces system-wide coherence. Late dosing can delay melatonin and disrupt sleep. Take it early for the strongest benefit. Align dosing with the clock. Morning. New inputs carry trade-offs. After use, NAD plus leaves NAM to clear. Some recycles, excess is methylated in the liver. NAM plus a methyl group becomes methyl nicotinamide and is excreted. Each clearance consumes SAM, your methyl budget. Depletion can raise homocysteine and strain neurotransmitter, detox, and epigenetic processes. Offset demand with trimethylglycine, often 1-to-1 with NMN at 500 mg and above. TMG replenishes SAM and keeps methyl groups available. Manage dose, timing, and methyl support to keep the system balanced. Any pro-metabolic input demands a cancer context check. Cancer craves NAD+, but NMN does not initiate cancer. Healthy cells an active repair guard against malignant starts. Concern centers on fueling existing malignancy. Avoid NMN with active cancer unless supervised by an oncologist. Mitigate with cycling to reduce chronic adaptation. Pair with senolytics and lower inflammation to shape a less permissive environment. The aim is enhancing healthy tissue resilience, not feeding disease. Think systems. NMN is the fuel layer in a larger stack. Add activation, resveratrol, pteristilben, leak control, apigenin quercetin, and mitochondrial aids, CoQ10, PQQ. Dose in the morning. Consider sublingual or liposomal for speed. Support methylation. TMG 1-to-1, above 500 mg. Cycle to maintain responsiveness and prudence. No supplement replaces training, diet, and sleep. NMN is not a stimulant, it restores signal integrity. Use NMN to preserve information, extend health span, and add life to years.